With the environmental challenge ranking as the world's most critical concern, the demand for clean energy through liquefied natural gas, or LNG, continues to grow. Responding to this need is a new type of LNG tanker, utilizing an orthodox self-supporting prismatic-shaped tank system. The world's first SPB LNG carrier, developed by Ishikawa-jima Harima Heavy Industries Company Limited, or IHI. This carrier furnishes a long list of superb performance features as an LNG tanker, along with stability, maneuverability, and structural strength, the most fundamental elements of safety. The SPB, the self-supporting prismatic-shaped tank IMO Type B LNG carrier, provides major advantages over all other systems in use today. Adopting a prismatic shape in its sectional configuration, the tank fits neatly into the vessel hold. This shape realizes a flat upper deck, minimizing wind resistance and ensuring excellent visibility from the bridge. The upper deck is almost entirely closed for outstanding structural strength. The low center of gravity supports solid hull stability during cargo handling, while navigational safety has also been enhanced. In designing the tank, computerized analysis technology was utilized to establish a precision grasp of the SPB tank strength. Unlike the storage tanks used on land, the rugged framework structure is built to endure severe stress on the open seas. As a result, this tank furnishes superb strength against vacuum as well, while the easy pressure control function greatly simplifies cargo handling work. In addition, a bulkhead curbs movement of the liquid cargo, eliminating sloshing problems regardless of the level of liquid in the tank. The SPB tank is a vital key to flexible route planning and expands the potential voyage range beyond set destinations to include unloading at a multiple number of terminals. The tank has a base-supported structure, with movement halted through a block guide anti-rolling chock system designed to permit free expansion and contraction of the tank from changes in cargo temperature. This crosswise arrangement of the block guides prevents the generation of high thermal stress inside the tank and greatly reduces the time required for cool down and cargo handling. The tank insulation system is designed for maximum efficiency. High-performance cold insulation is used on the tank surface, with top-caliber insulation materials in the tank supports and anti-rolling chocks as well. These features have prompted the successful adoption of the SPB system on LNG carriers of various sizes, including vessels 250,000 cubic meters or larger. Also in the planning are a floating LNG production storage and offloading system, or FPSO, LNG stockpiling facilities, and other new applications. This technology can also be applied to the transport of liquid hydrogen, which must be carried at the temperature of -252 degrees Celsius. The technology for this SPB LNG carrier has evolved from the rich experience of IHI in the cryogenic temperature field. Its proven superiority is visible in the construction of a large number of LNG terminals, cryogenic liquid gas carriers, and other stellar achievements. Today, the broad application and the outstanding features of this technology are emerging in the vital new capacity of a large-size SPB LNG carrier. The IHI Aichi Works, where construction of the SPB LNG carriers advances. In a superbly efficient facility layout, the aluminium fabrication process proceeds under a rigid quality control system. High-precision parts are manufactured through an end mill cutting process, utilizing a laser data transmission system. Instructions are input directly from the machining information center. The T-bar cutting machine works. The extensive use of such automated systems ensures outstanding levels of precision. Automation is a key part of the aluminium tank assembly works as well, supporting the top quality workmanship throughout the facility. In the automated welding processes, a broad selection of welding robots streamline the workflow. Automated high-current MIG welding. Automated three-way corner welding. Automated fillet welding. The aluminium tank welding is performed in a smooth configuration to avoid stress concentration. A meticulous quality control system is employed, using X-ray inspections and various measuring instruments at the weld points. An ultrasonic system also contributes to improving the level of quality. The construction of the aluminium tank moves through the sub-assembly and assembly processes, advancing onto the block assembly. The completed blocks are carried to the erection shop, where the final assembly of the tank is completed. IHI's industry-leading block construction technology plays a pivotal role in this phase as well. The stud bolts for installing the insulation panels are welded into place. IHI's exclusively developed automated seam welder also excels at this work phase, another example of how solid new technology boosts efficiency. The completed LNG tank, standing 21 meters high and 35 meters in both length and width. Inside the tank, a bulkhead is incorporated into the framework structure. At this erection shop, 2 tanks are constructed at the same time. The work to construct the LNG carrier's hull proceeds simultaneously at the building dock, preparing for the tank installation. The 2 tanks in the central section of the carrier have already been installed. The roof of the erection shop is opened and the 3rd tank is hoisted up. Two Goliath cranes are used to install the completed tank as a single integrated structure. The final tank installation. The tanks are built with an optimum waste-free design, and flexibly tailored to fit the dimensions of the carrier, enabling the ship to travel at faster speeds. The tank installation process proceeds right on schedule. Once the tank is in place, the work proceeds immediately to installation of the cold insulation panels, utilizing a work unit readied for this task. Adopted for the insulation system are polyurethane panels, fully prefabricated at the factory. When the installation is complete, cushion joints are inserted between each panel and sealed in place with tape. The thickness of the insulation panels may be easily increased, further lowering the gas boil-off rate to satisfy specific customer requirements. The anti-rolling chocks and anti-flotation chocks at the top of the tank. And the tank supports at the bottom. For maintenance and inspection, ample access space is furnished between the tank and the inner hull in the hold, including the top and bottom portions, maximizing safety and efficiency and reducing maintenance costs. On the upper deck as well, all work to install the deck fittings and the machinery is completed.
I name you Polar Eagle.
The naming ceremony unfolds in a festive atmosphere, and the newly completed LNG carrier is named the Polar Eagle. Following this, gas trials are conducted at an LNG terminal. These trials are utilized to confirm that the carrier's LNG cargo handling systems perform as designed. The gas purge, cool down, cargo loading, pump operation, insulation inspection, gas combustion, and all other functional operations are tested in actual ocean voyage conditions. The data generated by all of these tests satisfied the engineering demands. An LNG carrier with unprecedented reliability and economy, the primary targets of the SPB development. The Polar Eagle sails towards an LNG loading terminal in Kenai, Alaska. This agile carrier is able to berth under its own power, without tugboat assistance. Preparations for the loading begin at once. The loading arm is connected. And the loading of the LNG commences. When the Polar Eagle's 87,000 cubic meter tanks are fully loaded with LNG, the carrier departs for Tokyo Bay. voyage confirms that evaporation from the LNG tanks is minimal. Arriving in Japan, the LNG unloading is also completed right on schedule. The Polar Eagle, together with its sister ship, the Arctic Sun, continues to transport LNG from Alaska to Japan. The self-supporting prismatic-shaped tank, a tank technology with the longest history in liquefied gas transportation, has emerged as the SPB carrier system, a dramatic breakthrough in the safety and efficiency of LNG transport. This technology lends itself to a wide range of applications, extending beyond LNG carriers to other important new fields. The SPB system from Ishikawa-jima Harima, a technological innovation heralding the arrival of a new era of LNG marine transportation.